What do we mean by resilience? How does resilience explain occurrences that seem to happen unexpectedly or out of the blue? And can we find ways to measure resilience? By the end of this knowledge clip, we'll have answers to these questions, and you will find yourselves familiar with the following terms of ecological resilience and critical slowing down. To introduce you to the term resilience, we'll start with some examples. Imagine a butterfly that lands on a stone, leading to the stone falling. Was this a super strong butterfly that has the strength to displace a stone that's 1,000,000 times its weight? Or imagine a clear pond in a field. If somebody decides to feed the fish and the next week the lake is turbid, is this because fish food has tremendous impact on ponds? Or if one person, being imprisoned for the wrong reasons, leads to major riots in a city, is this because of that specific incident only, or is there more to it? Probably, these systems were already fragile, and that small disturbance just gave the last push to trigger a shift. In 1973, the ecologist Buzz Holling introduced the word resilience into the ecological literature and defined it as the maximal size of disturbance that a system can absorb without shifting to a different state. Now imagine the stone again. If the sand around the stone slowly erodes because of winds, the system becomes less and less resilient, but only when the butterfly lands on the stone does it fall. Similarly, a shallow lake or pond can slowly lose resilience because of eutrophication. And a society can lose resilience because of increasing poverty and inequality, where a relatively minor event can then lead to a large-scale social unrest. The loss of resilience can go unnoticed when looking at the average state of these systems. And in the examples, the position of the stone remained the same before it fell, the turbidity of the pond was low until the tipping point, and the society was at rest until violence erupted. Without knowing the system very well, we may still be able to indicate that a system is approaching a tipping point. A tipping point is a type of bifurcation point. It can be mathematically shown that if a system gets close to a bifurcation point, it will become slow in its response to external perturbations. And this phenomena is known as critical slowing down. We illustrate the concept of critical slowing down with a stability landscape. Here we have two landscapes, one where the system is in a state with high resilience, and one where the system is in a state with low resilience. If resilience is high, the slopes of the landscape are steep. The return rate from a perturbation is therefore high. If resilience is low, the slopes of the landscape are almost flat, and it will take a much longer time for the system to return to equilibrium after an external perturbation. Based on critical slowing down, there are several ways to monitor a system to figure out whether it's losing resilience. The most direct way is to perturb a system once in a while and measure the recovery rate. In reality, however, perturbations might be difficult to standardize, and one cannot always perturb systems experimentally because it's ethically unacceptable or simply not possible. Think of humans, societies, or the Earth system. Alternatively, one could monitor the system continuously and use the response to natural fluctuations to observe changes in resilience. A loss of resilience is then indicated by various statistical indicators, such as an increase in autocorrelation and variance. These types of resilience indicators have been proven to be useful in various complex systems, such as climate, mental health, and physical health. In conclusion, a system can appear stable, but be losing resilience all the while, so that it only takes a small nudge to shift it into another state. Whether a butterfly, a court case, or a handful of fish food. Measuring resilience through resilience indicators is thus important to give insight on critical slowing down and if the system is truly approaching a tipping point. Now you've learned about ecological resilience and critical slowing down.